Hello everyone. In today's session, I'm going to discuss about the top-down approaches techniques. So as I already told that a parsers can be done in two different patterns, that is by using the top-down approach or by using the bottom-up approach. Top-down approach is nothing but navigating from top of the parser and moving towards the leaves. That is, the parsing starts from the top root node and by placing the leaves at the left and right side, and it reaches the leaf nodes. And coming to the bottom up approach, bottom up is nothing but first it starts the parsing from the down level and reaching towards the reaching towards the top. So here we have a few different methods we can apply using the top-down and the bottom-up approaches. Here you can see a top-down approach can follow the two techniques or two methods. One is the backtracking. So this backtracking can also be called as this backtracking is you going to use the brute force attack, and another one is the predictive parser. And coming to the bottom up parsing, here we have SRP, shift reduce parser, and LR parser and operator precedence. Again, the LR parser has been divided into the three different methods, that is the SLR, CLR and LAR. So we are going to discuss in detail about each and every method in following sessions. So today I'll start with the top down approach. So first we are going to be discussing about the recursive descent parsing. So the types of recursive descent parsing are nothing but a recursive descent parser with backtracking and a recursive descent parser without backtracking. That is nothing but we can call a predictive parser. Here you have to remember that a predictive parser, nothing but which we are calling it as a recursive descent parser without backtracking. Different few names are there. So whenever you got the question in the examination point of view, you have to understand which method is this and how many names are there for this method. Then you have to start solving the given problems. So here we can call in previous slide we have seen that a top-down approach is having the two techniques, that is the backtracking and the predictive parser. So this predictive parser can also be called as the non-recursive descent parser. So predictive parser or non-recursive descent parser, both names are similar. If you are getting any either of the names, you have to follow the same technique or the same method. So here a recursive descent parser with backtracking, we can perform one technique using the same top-down approach, or without backtracking also we can perform the top-down parsing, but we can also call it as the predictive parser. Let's see in detail about each and every method. So here I have given the example how the recursive descent parser with backtracking is done. With the backtracking. So this example explains you how the backtracking is done with the recursive descent parser. So here whenever we say a recursive descent parser, it is by using the backtracking method. So that we are saying that in this method backtracking is needed and it tries to find the leftmost derivation. Here you can find left and left. That is nothing but if you choose one left, again in that left also you choose one more left. The left and leftmost derivation it follows for the construction of a parse tree. So here we have taken one example, some production like S derives some production and A derives some production. So for this given grammar, here we are trying to construct a parse tree. So and we have to get the string as CAD. Whether we are going to be checking the given string CAD can be accepted or error by using this grammar. So first we'll start with the initial state. So S is the initial state and S is deriving only one production, that is S derives CAD. So that I'm going to be starting the construction of a parse tree by following the top-down parsing. So top-down parsing is nothing but starts with the root node and reaches the input string. So I'll start with the initial state, that is yes. Yes is deriving CAD, CAD. And now C is the terminal and D is the terminal. Only the possibility here I can rewrite or I can substitute the production in the place of a non-terminal is only the possibility is A here. So that I'm going to be substituting or I'm going to be expanding the non-terminal A with its productions, So here why this method is choosing AB instead of A is nothing but, so here I told you one point that it chooses the leftmost derivation. So as A is going to be deriving two productions, that is A derives AB and A derives A. So in the given grammar, AB is the leftmost production, that is the first production which is producing by the non-terminal A, so that by default it chooses the left one or it chooses the first production which is derived by its non-terminal. So as usual it is going to be considering A derives AB. So now A is expanded towards AB. Now check the string what we have opened. So now here A and B both are also terminals. There is no further expansion is possible here. So we are stopping the construction of a parse string or deriving a parse tree for the given grammar. Why? Because to move the forward there is no chance of elaboration here. So now check what the string we got by drawing the construction of a parse tree. Nothing but C A B D. So the string what we got is the C A B D, but what the string we have to obtain is C A D. So here by substituting the first production, by elaborating the first production in the place of the non-terminal A, we are unable to derive the intended string. So that in such cases what the recursive descent parser is going to be doing is nothing but it backtracks one step previous. It backtracks one step previous. So backtracking is nothing but moving backward. So it can possible to move from the current position to the previous position by moving one step backward. So now it came to one step backward and it chooses the next production what actually A is deriving. So what actually A is deriving is A. So now we can check what the string. So further here A is the terminal, so no further production substitution can be possible. So we are stopping here for the elaboration of the parse tree. So now check the string what we have obtained here, C, A and D. So what we need to parse CAD. So it can be accepted. So now this parse tree is, this parser is success, or we can say successful. So like this a backtracking can be possible in the recursive descent parser with backtracking, where it allows the backtracking by moving one step backward, that is nothing but moving one step previous step and choosing the next production which is derived for that particular non-terminal. So here it fails to obtain the string and chooses the backtrack, and then it goes for the next production and substituting A in the place of non-terminal A, and now CAD is the string what actually user needs, and this parse tree has been successfully got the string CAD. So this is about the recursive descent parser. So here I have given one more example for the clear understanding of the recursive descent parser using the backtracking. So here we have only one production, that is, but this production is having the, this grammar yes is having the three different productions. So we, for understanding purpose, so this yes is going to be deriving this one and this one and this one. So three production values consisting of the grammar, and this is the input string what we should parse by using this grammar. So finally by parsing the given grammar we have to check whether the string AB can be parsed or we are going to be getting the error. So as of the rule of the construction of a parse tree, the construction of the parse tree should be starts with the root node. The root node will be initially considered as the starting node or a starting production non-terminal. So here we have only one production yes, so that we have taken the yes. So here definitely by default it is going to be choosing the first production which it is derives. So it chooses the first production. So yes derives A yes B S. So now what we have, this A is the terminal, so here no possibility of further elaboration, and here no possibility of further elaboration. Only where we can do it, this yes and this yes, but it follows the leftmost derivation, so that it has to choose the leftmost non-terminal to elaborate, so that this yes is also going to be choosing. So in this step also it is going to be choosing the again first production. Always it considers first production only unless it finds out the parsing fails, it keeps on choosing the first production only. So again this S is also replaced by AS BS, that is the first production. And once before elaborating further, we have to check whether whatever the needed string is getting or not. Why? Because when it chooses the wrong production and it fails, it can only backtrack one step backward. After parsing complete the parse tree until we don't have any expansion, we stop over there, and if we check the string, if the string is not if the string not matches towards the input string, then we cannot backtrack all the steps backward. So that for each and every step we have to check whether we are getting the input string, if input string is possible or not. So that now we are going to be checking. So A is here, and here also A is A, but we need A after B, so that by checking only these two terminals we can understand we didn't pass the whatever the string we need, so that it understand here it fails and again goes for the backtracks. Backtracks is nothing but only one step previous, so that it can backtrack only by substituting these values. So again now it goes for the second production of the given grammar. So now in the place of yes, it is going to be elaborating by using B yes A yes. So now it will check A B. So A B is there, so that first two characters of a given string are matched. So next X is there, S is there, and again A is there, and again B is there. So here again three non-terminals are there where we can elaborate it. First one is this one, second one is this one, and the third one is this one. So finally we have to make sure that after completion of a construction of a parse tree, no more non-terminal should be available in the leaf nodes. All the leaf nodes should be the terminals. Then only we can stop elaborating, or we can stop parsing the parse tree or the syntax tree. So we have to remove all these non-terminals in the grammar. So we are going to be substituting again one more in the place of these non-terminals. Again we start here. So directly I have written here, for suppose here again it chooses with the first production. By default it chooses with the first production, that is what the first production is there, A yes B yes. So again for each and every step it checks for the whether whatever the input string we need is going to be parsing or not. So we are getting A B A, okay, A B A is there, and after A after B is there. Okay, up to here we got the string, but extra A is there and still few more non-terminals also there. So by checking this, it understand it fails and again it has to go to the backtrack. So after going to the backtrack, now it will check for the second production available in the grammar. What's the second production? Second production is B yes A yes. So again it will check for the input string. What the input string? AB is the input string, and what we parsed here, AB, B after again we have to get the A, but here it is B. So now it can understand again the parsing is fails, and again it goes the backtrack. Now it chooses the third production of S, that is the epsilon. So now it will check the input string AB, and AB is there. So now the string what we got is success. We got the input string what actually we need, but still we need two more non-terminals to replace. So again it will start with this yes, and first it will check for the first production again as usual, AS, BS. Again this is not matched with the input string. Again it go to the backtracking and again chooses the next production, that is BS, AS. Again we have AB, B, which does not matches with the input string. Again it backtracks, and now it go for the third production, that is the epsilon. So now it will checks AB is there. So now the string is there, but still one more non-terminal is there. So in this non-terminal also, first it is going to be replacing or elaborating with the first production, that is AS, BS, which does not matches to the input string. Again it chooses the backtracking, and the second time it chooses the BS, AS, which is not again matched with the wanted string. So again it is going to be backtracking, and now at the third time it replaces with the epsilon. So now it is going to be checking AB, the string is there, and no more non-terminals available in the parser to elaborate. So it stops constructing a parse tree and checking the final string, that is A, B. So what the input string is AB. So the string AB has been successfully parsed with the help of the recursive descent parser with backtracking. So such a way it is going to be selecting the leftmost non-terminal to replace with its production, and in each and every step it is going to be checking whether the input string is going to be parsing successful or not. Like that it checks, and it's keep on constructing a parse tree until there are no more non-terminals to elaborate. But here you can observe each step it has to check for the input string, which consumes more time, and each non-terminal first it is replaced with its first production. If it not matches, then again it has to follow the backtracking and again applies the second production. If matches, it's okay. If does not matches, again it goes for backtracks. Like that for each and every non-terminal, how many productions are there, every time it starts with the first production and keeps on checking each and every production, which consumes much time for the for construction of a parse tree. So to avoid such time consumption and the disadvantages which are going to be arising by using the backtracking technique, it can be overcome by the next techniques, that is the non-recursive descent parser without backtracking, or we can call it as recursive descent parser without backtracking, or we can call it as non-recursive descent parser, or we can call it as a predictive parser. These are all the similar names where we are going to be applying the similar technique. So next, moving to the predictive parsing, or we can call it as LL1 grammar, or we can call it as recursive descent parser without backtracking, or we can call it as non-recursive descent parser. So there are some rules to be followed to apply the predictive parsing method to check whether the given input string can be parsed successfully by using the given grammar. So the first one is, as in the previous session where I have explained about the elimination of the left recursion and elimination of the left factoring, there itself I have given a clear description about why the left recursion and left factoring should not be considered in the grammar. So the top-down approaches or the top-down methods cannot solve or cannot able to apply the methods for the input string to be accepted or error if the grammar is consisting of the left recursion and the left factoring. So to apply any technique of top-down parsing, the grammar should be free from left recursion and the left factoring. And especially to apply the method called predictive parsing along with the elimination of left recursion and left factoring, we have to find out the first and follow functions of a given grammar. First and follow functions of a given grammar. So before explaining about how the predictive parser is done, first I have to discuss about, or first I have to explain about how the first and follow functions are going to be calculated, or how the first and follow functions are calculated for the given grammar. From the obtained result, we can apply the predictive parsing method. So in a session, I'll explain about how to get the first and follow functions of a given grammar.